once again, thank you very much, Liberty, for this opportunity. And please go and follow Tenfold Education app as well. Now, we've answered the beautiful question regarding line thunderstorms. My next question is from Katlego. Now, Katlego has got a geomorphology question over here regarding runoff. Okay. Now, if we look at the question, let's just go and have a look at our diagram. And the question, the diagram basically focuses on surface runoff. Okay. But we need to go and have a look at runoff. What is runoff? Very importantly, when we introduce geomorphology, first of all, we look at the surface. We look at fluvial geomorphology, at rivers mainly. Now, water flows in two ways: surface runoff or underground runoff. We also refer to it as direct and indirect. So before I'm going to answer the questions and before we're going to look at this diagram, let's just have a look at the difference between surface and underground runoff and how to differentiate between the two of them. Okay, so I just want to get my color pen. So we got two different types of runoffs: surface, also referred to as direct, and underground. Indirect. Okay. So when we talk about runoff, we actually talk about water. Okay. So we're going to have a look how does the water flow? Does it flow on top of the surface or does it flow under the ground? That's how simple it is. When it's on top of the surface, it's direct runoff. It's on top. Give me a couple of examples. Rivers, lakes, okay, deltas. All these are surface runoff because the water is on top of the surface. Underground runoff is water table. What does the water do? It infiltrates. That's what it does. So it infiltrates into the soil and eventually in underground and eventually in underground river channels, water tables where it collects. And eventually that beautiful process that we know as the hydrological cycle or the water cycle, eventually back to the ocean. Okay. But keep in mind, we have many factors influencing how water flows. There's factors that will determine if water is going to flow on top of the surface or that it's actually rather going to infiltrate. Okay. These factors play a huge role. And once again, we as humans also contribute to these factors. We also determine how the water is flowing. And once again, there might be positive and negative aspects regarding that. Now, for instance, when we look at our diagram, urban area, pay attention, they've given us statistics over here. And let's just pay attention to the diagram. An urban area, as you can see, what is an urban area? We've discussed it many times. Okay, urban areas where secondary, tertiary activities takes place. Okay, we look at it, like for instance, it's build-up, it's infrastructure. You can see the buildings. And like they've shown you over here, look at the percentage they've given us over there. 90 to 100% runoff. So let's just assume this means surface runoff. So that's what they mean. They mean it's going to be 90 to 100% surface runoff. So what they're trying to tell us over here is that water is not going to infiltrate. It's not. So the water that we're going to see in the urban area is going to be on top of the surface. Okay. We're going to see it. It's not going to go underground. When we go, once again, they've used keys to represent, just to give us an indication of the volume of water. Look how thick the arrows over there. They've mentioned this. The thickness of the arrow refers to the volume of water. So obviously, as you can see, the arrow is much thicker on the urban diagram than at the cultivated area or the forested area. So it means there's going to be a high volume of water. Okay. Because the arrows are the thickest. Now let's just quickly move on to our next image diagram. figure basically. It's cultivated land. Even though it's vegetation, it's man-made. Now pay attention, I've just written over that. Pay attention to the surface runoff that's been experienced over here. 50 to 60%. Okay. So it means it's 50-50, am I correct? So there's direct runoff as well as indirect runoff, underground runoff. So some of the water infiltrates. That's what they're telling us over here. Not all of the water is going to stay on top of the surface. Okay. Keep in mind, it's cultivated land, still vegetation. Now, if we go to our last figure, it's a forest area. Look at the runoff. 10 to 20%. Then have a look at the arrow, the size of that. It's by far the thinnest between the three of them. So it means it's the volume of water is the lowest. Not much surface runoff. So it means we're not going to see much water on the surface. Yeah. At the cultivated land, it's a mixed bunch between the two of them. But now, before I'm going to answer the questions, we're concentrating on surface runoff. And I want to go back to these factors that determine which one is which. No, not determine which one is which. It's an influence. So I'm going to talk about promoting, and I'm going to talk about retarding. It's going to promote that there's going to be more water on the surface, and retarding means it's going to cause that there's less water in the surface. And when I discuss this, we talk about the factors influencing runoff. Okay. Now we distinguish between the surface runoff on top of the surface. Just want to write it there. And we looked at underground or indirect surfaces when the water infiltrates. Now the first factor that influences runoff is very simple, rainfall. Okay. Now in our previous question, we looked at it, for instance, we looked at the eastern side and the western side. Now for instance, if it rains more, depending on the rainfall of the area, if it rains more, there's going to be more surface runoff. It's basically simple explanation. If it rains more, it's going to promote surface runoff. Okay, promote surface runoff if it's high rainfall areas. Okay, so that's quite straightforward. There's nothing to explain. You know, if it's going to rain more, it means there's going to be more surface runoff. Okay, simple as that. The next factor that has a huge role over here, we can say, is vegetation cover. Okay. Now, what does vegetation do? I want you to assume, and then we're going back to our figures. If you look at urban areas, does it consist a lot of vegetation? When I talk about vegetation, I'm talking about plants and I'm talking about trees. Okay. As you can see, the urban areas, there's almost no vegetation. We look at it, it's artificial surfaces. Am I correct? When I say artificial surfaces, it's fake. It's man-made. For instance, a tar road surface. Okay. In contrast, if you go to area C, you can see it's a forested area. It means there's a lot of plants, a lot of vegetation, such as trees. Now, what does vegetation do when they receive precipitation? What do they do with the water? They absorb. So what do we say? What's vegetation going to do? Is it going to promote surface runoff, or is it going to promote underground runoff? Definitely underground. Because what is the water going to do? It's going to infiltrate. Okay. So let's just write down there. Vegetation, it's going to promote underground runoff or indirect runoff. Okay. Now, very important as well, we need to look at the permeability of the underlying rock or soil. Okay, so we're going to have a look at both of them, rock and soil, and I'm going to give you a couple of examples. Now, what does permeable means? Permeable means a permeable rock allows water to infiltrate. Okay, so if you take a bucket of water and you throw it over that rock, the water will infiltrate. Okay, an impermeable rock doesn't allow water to infiltrate. Let's write it down, make notes. Okay, permeable allows water to infiltrate. Impermeable doesn't allow water to infiltrate. Okay, so one of them allows water to infiltrate and the other one doesn't. Now keep in mind, when I talk about permeable areas, right, soil is going to be permeable. But keep in mind, man-made surfaces that we create might be impermeable. So going back to our images, you look at it, think of it. You look at this urban area over here. It's covered. It's covered with tar road surfaces, as you can see over here. It's covered with pavement, with concrete. So what does we as humans do? We create impermeable surfaces. So it means we create surfaces where the water cannot infiltrate. And that's the reason, going back to our figure, it shows the thickness, the volume is going to increase. There's going to be more water on top of the surface because we have created an impermeable surface. It means because of the tar road that we've built, because of the pavement that we created in our urban areas, the water won't be able to infiltrate. But if you go, I'm skipping the cultivated lands over here because I'm going from the one extreme to the next. If you look at the forestry area, only 10 to 20%, because most of the surfaces in this forested area consist of soil, okay, consist of permeable rock, okay, consist of permeable surfaces. Now, we can go and have a look at it as well. When I talk about the different types of soil type, okay, very important. I'm going to use the one extreme to the next. Let's think of clay, for example. On the one side, we have clay. On the other side, we have sand. Now, clay, what does it do? We usually find it in riverbeds. Okay, so what does clay do? In matter of fact, it does absorb. What does it do? It absorbs the water. But then we say, because of the soil type that clay is, it gets saturated. Okay, almost like it's full. Like for instance, I want you to imagine a sponge that you do your washing with, your dishwasher, when you're washing the dishes. Sorry, apologies. So that same sponge, what does it do first when you put it underneath the tap? It absorbs all the water. And once the sponge is saturated, what happens with the rest of the water? It just flows off the sponge. That's very similar to clay. Okay. So what does clay do? It absorbs the water, it gets saturated, and then what does it do? It becomes basically impermeable. It doesn't allow water to infiltrate. And that's the reason it creates riverbeds. It doesn't allow the water to infiltrate. Okay. On the other hand, like I've mentioned, we've got sand. Okay, so what happens with sand? Just assume we've got a bucket of water, okay, and I throw it into a bucket of sand. What's going to happen with the water? It's going to infiltrate because the granulars are far from each other. Okay, there's gaps in between. So what do we say about sand? It's impermeable. So let's just assume if you look at this forested area on our map, think of it, lots of vegetation, so it absorbs the water, and so we can say lots of vegetation over here. Okay, lots of vegetation and permeability. Okay, and as we can say, we can mention over here, impermeable. So that's some of the factors. So we can throw that in with the type of soil and the underlying rock. Okay, now very important, keep in mind, it can be human structures as well. Another reason we can add over here, so we look at the permeability of underlying rock, the vegetation. Very important, we can look at the gradient. Okay, steepness of the slope. Okay. Now, this is determined, when we look at gradient, we can have a look at two examples. We look at a gentle slope and a steep slope. It's right there. Gentle and steep. Now, let's assume it rains. Okay, and I'm going to use two examples. I'm going to use a mountain, and I'm going to use the rugby field at your school. Okay, and if I can draw, there's your rugby field. Okay, there's the mountain. As you can see, it's a steep gradient. Which one will promote surface runoff, and which one will promote underground runoff? Now, let's assume we experience a massive thunderstorm and it rains. Okay. Do you think there's going to be time on these steep slopes of the mountain for the water to be infiltrated? Definitely no. Okay. Because the slope is so steep, what's going to happen? The water is going to start flowing, right? We're going to experience, in fact, turbulent flow. Okay, in case if it's a river. But because the water is going to move because of gravity, there's going to be no time for the water to infiltrate. So what is a steep slope going to promote? It's going to promote surface runoff. Okay, but now we've mentioned the rugby field, for example. It's basically a flat area. What happens? Let's say, for instance, up here in Joburg, we usually see it. What happens to the water? It rains, line thunderstorms or isolated thunderstorms during summer, a hell of a lot of rain between 3 o'clock and 5 o'clock in the afternoon. What do we see with the water? It doesn't go anywhere because it's a flat area. What happens with the water? It infiltrates. So what's it going to promote? It's going to promote underground runoff. Okay. So if we look at these factors that influence the runoff, when I say the factors, so these factors determine if the water is going to go either into the ground, underground, or going to stay on top of the surface. And it's very simple. It's the rainfall, depending how much rainfall they experience, vegetation cover, lots of vegetation, less vegetation, the permeability of the underlying rock. Does it allow water to go in or not? The gradient, how steep the slope is or not, how gentle it is. Okay, so all these factors, and I'm going to quickly throw it in here when we look at that. Then we need to answer our question. Let me just quickly clean our diagram. Yeah. Now, if you look at our urban area, we can identify, we can see that the runoff is 90 to 100%. So there is basically no infiltration taking place in this urban area? Now, first of all, we might say, even though it's all of them, let's assume A, B, and C have the same amount of rainfall, right? So rainfall is not going to be a factor, it doesn't matter. So the volume of water is still going to be great over here, because if you look at the permeability of the surface area, all of the areas are basically impermeable. It doesn't allow any water through. Now, another factor that we look at, vegetation cover. We looked at it. Vegetation cover promotes infiltration. There is no vegetation in this area. Okay. No grass, no trees. That's going to promote infiltration. And if you look at the steepness of the slope, it doesn't matter if it's going to be steep or gentle, but because of the surface that's been created, it's going to create 90 to 100% runoff. If you go to cultivated area B, yes, I know it's covered with vegetation. Yes, it might be, if you look at the area, it might be a little bit steep. So yes, some of the water is going to be able to infiltrate, and some of the water is going to be able to run off. Why? Because it might be because of the permeability that's been created by the farmer. Okay, what did the farmer do with permeability? What type of soil did he use, for example? On what type of gradient did he start to plant his crops? Okay, very important. And then last but not least, the forest obviously promotes the majority of permeability, the majority of surface runoff, because it's covered with grass, it's covered with vegetation. It promotes infiltration. Okay, either way, it can be a steep gradient or it can be a gentle gradient. It's covered with a lot of vegetation, and it might experience a high rainfall area as well. Now let's just quickly have a look at the question. Okay, define the term surface runoff. I've mentioned that to you. When water flows on top of the surface. Now, question 1.5.2. On which landscape? Now, just for instance, we can just write there, for example, a river. Okay. In which landscape is the highest surface runoff recorded? Now, they've mentioned there's the three runoffs. Urban, cultivated, forested. Definitely 90 to 100%. And the correct answer is going to be the urban landscape. Okay. Now, question 1.5.3. State why the surface runoff and the landscape you selected in question 1.5.2 is higher compared to the other two surfaces. Now, we looked at that and those factors that influence the runoff. And let's just quickly do it again. Let's just mention it again. Okay. First of all, of all the artificial surfaces that we find in the urban area, okay, it's impermeable surfaces, so water can't infiltrate. And the second reason we can say there's less vegetation cover. Okay, there's less vegetation such as grass or plants. Now, if you look at question 1.5.4, if we compare the runoff on the cultivated surface, as you can see, it's basically 50-50. Indirect and direct runoff. Some of the water infiltrate, some of them don't. Whereas the forested area, 10 to 20% indirect runoff, underground runoff. Now, if we look at 1.5.4, we need to compare these two with one another. Okay. Even though both is covered with vegetation, but one is man-made vegetation in comparison to the forested area. There's a massive difference between runoff. Now let's just quickly discuss this question. How has the process of infiltration influenced the difference in recorded surface runoff? Okay. How has the process of infiltration influenced the difference in recorded? Now, as you can see, there is much less infiltration at the forested area than the cultivated area. The simple reason for that is because there might still, even though it's crops, there's less vegetation on this area than in the forested area. Okay, because there's a biodiversity of different types of different plants, whereas in cultivated area, all of these plants are probably the exact same type of vegetation. Now, if we look at question number B, describe the impact of the level of infiltration on the groundwater levels for both surface B and C. Now, the impact, we're going to have a look at a water table, for instance. For area C, the forested area, is going to be absolutely lovely. It's going to be absolutely beautiful. Because what's going to happen? The majority of the water, let's assume it gets rainfall, what's going to happen? It's going to infiltrate. So it's going to be a very healthy system that we experience at sea, because all the water is going to collect in the water table, underground water. Okay. Different story at the cultivated area. Okay. So obviously there's going to be less, the water levels are going to be much lower at area B, because the water are being absorbed over here. Okay. So that's what's happened. So it means for irrigation purposes, there might be less water. Now, if you look at the last question, 1.5.5, suggest how increased runoff can be managed by referring to urban and cultivated surfaces, as shown in the diagram. Now, what can we do? What can we do to save this water? Okay, urban areas already done it. What do? We've got stormwater drains. Okay, we've got gutter systems. Eventually, these water will flow to collection points. Might even be dams. Okay, so urban planning takes place where we can actually try and collect that water. From a cultivation point of view, this water might be collected in dams. And in turn, once it's collected in dams, it can be used for irrigation purposes for the crops to grow. Okay, Katlego, thank you for this question. Absolutely love it. I hope I've answered the questions that you would have liked the answers to. And we're quickly going to take a short break. Once again, stretch that legs, grab a cup of coffee, grab a glass of water, and after this, getting back straight into it.